Hey guys! Okay, so today we're going to get into a little bit of organic chemistry. So, we're going to start with our organic compounds. And first up is hydrocarbons. Now, let me change this color. It's a little not good. Okay, so for hydrocarbons, these are compounds that contain only carbon and hydrogen. That is not isohydrogen, sorry. Okay, so the biggest thing with hydrocarbons is that we have to remember some prefixes. So, if we have one carbon in it, it's meth. And then if there's two, it's eth. 3 is prop. 4 is but or bute. And then 5 is pent. 6 is hex. 7 is hept. 8 is octa. 9 is non. And 10 is dec. So when we add these to each of our hydrocarbons, that shows us how many of the carbons that we have. So let's say we have C4. Let's just start with that. It doesn't matter about the hydrogens right now and how many there are. But because we have 4, and let's say we have all single bonds, so then this would become butane. And this ane comes from the bonds that are in it. So it goes ane for only single bonds. Ene is 2. And then it's that it's ein, I believe. I don't really know how to pronounce that, but oh well. So that is going to be 3+. So if there's at least one triple bond in it or more. So technically this but could be butene or butine. Sure. So those are our hydrocarbons. Next, we have our alkanes. So, alkanes are our simplest class of the hydrocarbons, and an alkane is when each carbon is bonded to 4 other atoms. When we have one carbon, we have either H's or whatever connected to it, so there's 4 others, so it actually has a complete octet. So the most simplest ones that are often used are methane, ethane, and propane. After the alkanes, there's another specific group within the alkanes that makes alcohols. So it's called a functional group, and that's basically just when one part of it is connected by another. So they're kind of just replaced by specific groups. And so in an alcohol, at the end of an atom is replaced with an OH group. For a definition, it would just be an alkane with So, let's say we do have methanol, and actually this right here is methanol. So let's say we have methanol, we have methane, that's my fault, and we're going to add an OH group right here. So this is actually going to become an OH group, which will then make methane an alcohol. And so if we do have the C, and then I'm just going to make a little rough sketch. Let's just say we have all these H's. This would be methanol rather than methane. So that's basically all that's different with alcohols, just at that all ending. Next are isomers. They are compounds that have the same molecular. Well, essentially the best way to think about this is that they have the same amount of things, but they just look different when it's all put together. Okay, so now we're going to go a little bit farther into our hydrocarbons. And these are just some little things and like tricks for you to help name these compounds. So let's say we have the hydrocarbon, we're just gonna do propane. So we're gonna do 1, 2, 3 because meth, eth, prop, and then we're just gonna make it an alkane. So we're just gonna make all of these and then add our H's. Okay, so this is propane. And we say ane because these are only single bonds. Right here. Single bonds. So, now, let's just say we add a little double bond right there. Okay, so then this would become propene. Because we have that double bond right there. But, specifically, when we have compounds, you want to name where they're at. So, because this is connected to the first carbon, it's going to be 1-propene. And that's just a little way that we name the hydrocarbons and the alkanes. Just makes it a little bit different. So, I mean, technically, if I want to be correct, this should be off there. Just because 4 bonds and octets and whatever. But anyways, so yeah, that's how that's going to work. But let's just say that this double bond was actually on this side. Now, that wouldn't change the name because technically you could still say that that's the first hydrocarbon. Or that's the first carbon of the group. So, technically it would still be 1-propane. And now, once you get into like bigger ones and you get into the nons and whatever, that's where the numbers really come in handy when you're going to talk about the structures themselves and how stable they may be or whatever. So, now we're going to do some example problems. We have the problem for this exercise. It says A. What is the molecular formula of hexane and the alkane with 6 carbons? So, when we have hexane, we know that obviously we're going to have C and H, and we're going to have 6 because it's hexane, and that's 6. Now, I usually draw this out, but there are some tips and tricks. When you count all of that up, it's actually going to be 14 hydrogens. And basically, the way that you do this, as long as there are single bonds in it, you can basically just, all you really have to do is double this, which will give you 12, and then you add 2. And that's basically the easiest way to do it. So, this is our molecular formula for hexane, and this would also be the alkane. Next is, what are the name and molecular formula of an alcohol derived from hexane? So, we know that with our alcohols, all we do is add an OH at the end. So, let's just pretend that the rest of these are H's. I'm just not going to write all those out, whatever. So, we're going to make this our alcohol. So, technically, this would be called hexanol. That sounds very weird, but that's how it's supposed to be. And that's all you really do for that. So the molecular formula of that would technically be C6H13 and then OH is really how it would be written, or sometimes it can be written as C6H14O. But technically, this would be the correct formula for it. I think that's about it. So there you are.